Okay, welcome. This is the Patterns Chemistry Unit 3 webinar on nuclear chemistry or nuclear technology. I'm Carly Harris. I am currently a teacher in the Beaverton School District, and I also am a member on our chemistry council that we have with some Portland Metro school districts, as you probably know. I am currently teaching at Beaverton Academy of Science and Engineering, also known as BASE. And funny enough, I'm not teaching chemistry currently, but I do teach some biomedical science CTE courses. I have been on the chemistry council for, how long has it been? Is it maybe 4 years, Christy? Somewhere around there?
Oh my gosh, it's been more than that.
Maybe more than that. 5 years? It feels like
5 or 6. Yeah, long time.
5 or 6. Okay. Do you want to introduce yourself, Christy, real fast?
Sure. My name is Christy Miller. I'm also on the Chem Council. Carly and I hosted this webinar last year, and we'll also do Unit 4 together, which will be next month. I'm in a supporting role for Carly tonight, but looking forward to talking about Unit 3. It's a super interesting unit, and oh, there's an echo there, and lots of great student hands-on things to do. We'll also be, I also facilitate the equitable grading PLC, so I recognize some names here that attend that too, so welcome, glad to see you. And take it away, Carly.
All right. So we'll give you all the information here for attendance and all the links and stuff that you need. I know Christy, like she said, she's in the supporting role. She's putting in the links for the slideshow that we're going to be using. And the slideshow has a lot of information embedded into it. Spent a lot of time getting all the links in. If you have visited the PMSP webinars in the past, you've probably seen Jome Sika and Andrea Leach. They did units 1 and 2, and you can find access to those. I think they're being uploaded to our YouTube channel, and those are available if you've missed those webinars. I love doing the Unit 3 webinar because for me, personally, this was a unit that I didn't ever teach really until I started teaching patterns curriculum. Nuclear technology was literally like chapter 12 maybe of the textbook, and who gets to that, right? And I really just grew to love the way that the curriculum has the phenomena set up, and so now I love promoting Unit 3 and trying to get teachers to buy in and teach this unit. So I'm here to show you kind of the way of how, it's set up in terms of its scope and sequence, but hopefully I can give you some little tips and tricks along the way too. So let's go to our attendance. So we just make sure we can get that done, and then I'll show you all the links and how you can access things. And of course, you have access to this slideshow too, so you can skip ahead if that's what you would like. If you are an organ teacher, which just looking at a lot of the names here that I've seen before, I know many of you are organ teachers, and we have the RAP grant that can get you paid for being here, which is awesome. So you should see some links here where you can access a Google form, and I'll probably be going like in and out of slideshow presentation mode here, but it does look like, maybe I don't have it open. This is what it looks like. It is just a good old Google form. And so if you could just check off Unit 3 here and fill that out for us, then that will be fantastic. We'll have a record of your attendance. And then if you would like to get paid, there is another link to click on here for the Wild Apricot. And if you've done this before, there's kind of a system in place with PSU, Portland State University. If you have not done this before, check out the video because it will tell you exactly what you need to do. Okay, so if you have any questions like related to that, you can put into the chat, and Christy can help you out with that. All right. The next thing is accessing all the resources that we'll be talking about today. You have access to our Patterns Chemistry website, which this will take you to all the different units. And I just want to point this out because some teachers access our resources through the Google Drive, the shared drive that we have. And I just want to make sure that you know that this web resource is here. So we'll be working in Unit 3 today. We have updated our website, which I'm very excited about, so that the in-person unit planner is first. I know a lot of our teachers also teach distance learning, or like an online version of chemistry, right? So that is still here. It's just down at the bottom. So we're going to be working on switching those. It can be a little confusing on some of the other units, to be honest. And that's just a tech thing that we're getting around to finally fixing. So this is our unit planner. You're welcome to open this up and access like the full document as needed. And then I do have a link to our shared drive. We use the Google shared drive system now, and this was, you know, we switched over to this in the summertime. I know Christy did a lot of work on this, and so you probably received some emails, but we just want to make sure that everyone that is attending has access to the open access shared folders, the new ones, right? Not our older ones that we had as things have been moved, and then our restricted access. So there is a link if you do not have access to the restricted drive, you can do that. And I believe it's Christy that gives you the ultimate access. So send her a little message and she can help you out with that. And then the last link that I wanted to share with you is specific to our webinar today. And this is our idea capture tool. And so if you could just, you know, pop in here and you should be able, well, I should check the shared access. Since this is a new document, I think you need to be editor. There we go. Okay, you should be able to edit this. So you can just leave us some information about like, why are you specifically here for the Unit 3 webinar? We would love to hear that. And then what would you hope to learn from this webinar? That helps inform our future webinars as well. And you know, if I can see this, then, you know, on the fly, I might be able to help answer some of these or do my best to serve your needs. And then there's also a place here for some questions. Of course, you can use the chat box too, but maybe if you have some other just patterns chemistry in general questions, you can leave those questions there. If you want to leave your name or your email, that might be something that we can address as well, you know, in another email. So we just want to make sure that you feel supported and that you have all the resources that you need. And if you have any specific questions, that we can address them to help you help your students. Awesome. And we're getting some information in there already. Okay. No worries, Carrie. Glad you're here. Be safe driving. We are just filling out a document just to capture like why we're here and the things we hope to learn. And we have some also webinar attendees today, so that's fantastic. We appreciate you. Okay. Awesome. Well, these two right away, I know that we can help with today for what do you hope to learn? Let's just put this on the next page. There we go. Okay, so we are going to go over some ideas for teaching nuclear decay. We have a little sorting activity that we'll talk about. And then something that's nice about Unit 3 and the nuclear technology is that there are some shorter lab activities. There's like a lot of them, but they're shorter. And so I actually mapped out a lot of the timing. And so you can get unit 3 done a lot faster than unit 1 and 2. So there's my little plug for making sure to get unit 3 done. Okay, awesome. So we'll take a look at these and get back to them as needed. But let's hop right into things. Before I start, I won't spend too long on here because I know we have a lot of familiar faces, but I just want to put out the design principles for our work. So we have our physics, our chemistry, and our biology courses, and all of our courses are designed around our design principles. So we believe that our work should be student-centered, right? So our students are doing the work in their learning. We believe that our courses should include collaboration. We have a pretty cool approach to science inquiry. This is like the patterns approach, culminating in having our students make data-informed predictions. I love this. I use this in a lot of my other courses that are not patterns. I think it's a fantastic approach to science inquiry. We have a unique patterns approach to engineering, which we see throughout our course. Unit 3 doesn't really have an engineering project, so that's interesting to point out. If you have any ideas, we would love to hear those ideas. And then we also have our course designed around being culturally responsive. So we are intentional about that. We work our best to provide differentiation for our students, to be language rich, right? So we're encouraging student talk and writing and using academic language. And then of course the 3D assessment, which is a challenge. We've been talking about that a lot as a council, and it's challenging. So if you want to just put one of those 8 things that's just kind of resonating with you, I'll flip through them. I know some of you are still writing up your ideas, but if you want to put any of those in the chat, that's just kind of speaking to you a little bit, that would be great. So maybe this could be something that you personally are working on in your classroom, or something that you appreciate about patterns curriculum. So you can put those into the chat, either student-centered learning, collaboration, the patterns approach to inquiry. We've got engineering, and then culturally responsive, differentiation, language rich, and 3D assessment. And if you wanted to learn more about the design principles, there's also a document linked in our slideshow in the notes down here at the bottom, and you're welcome to kind of peruse through those to learn a little bit more about that. All right. Well, I think everyone hopefully is here that was wanting to show up. So let's go into our Unit 3 nuclear technology. I'm going to point you to this Unit 3 walkthrough. And the walkthrough is an overview of the whole unit. So we're just going to take a quick little look at this, and I have a visual to go along with this. But we've been updating all of our units to include this walkthrough that of course like goes over the main scope and sequence. But then we've divided it up by task set so that you have a better understanding of how long this could take, We've included the phenomena and the essential question, what students should know now, like before they're starting the task set, what exactly students will be doing and what we want them to learn. So we've revamped this a little bit. We had an existing document, but we've tried to add a little more substance to this. So this will be a really helpful tool in your planning as you're trying to make decisions for what's best to do in your classroom. So this is our Unit 3 roadmap, and we're going to hit all of these task sets in our webinar tonight. We'll start with the Unit 1 opener that has our phenomena, and then we'll talk about task set 2, which we call Units in the Stars. Task set 3 is all about stability and radioactivity. Task set 4, types of radiation. Then in task set 5, we have a half-life lab, and task set 6 is our culminating activity. It's a nuclear technology. It says debate, but it also could be a discussion, right? So we're going to visit each of these along the way here and just have a broad overview, but also some opportunities if you have any specific questions or would like to see a particular part of the task set a little bit better. So like all of our units, we have a slideshow that we just call our unit opener. And this serves the purpose for our students to engage in the unit phenomena. And the idea is that we're not just using this phenomena right at the beginning, but we're bringing it up at the beginning for our students to create a driving question board, which we call a DQB. And then this phenomena is leading our conversations throughout the whole entire unit. And for this unit in particular, what I really enjoy and love is that it's super easy to use this phenomena throughout the whole entire unit. And I think this is one where we do the best job of it as the content creators in the Chemistry Council. So with the unit opener, the way that it's set up is to help give some students the opportunity to develop these questions. So at the end of the unit, they can engage in a debate or a conversation related to nuclear technology. And so in the beginning, in this opener, we prompt them with the question, as a global society, should we continue to develop nuclear technologies? Yes or no, right? Some students know what we mean by nuclear technologies, but most students don't. So we have just a couple videos that are short here to kind of give them some examples of what we're talking about when we talk about nuclear technology. We relate this back to our nation and what we might do in terms of storing some of the byproducts of using this nuclear technology. And so there's an article here that students can read that talks about these nuclear waste storage sites, and a little map where we have students kind of engage in this. And then we propose a question for our students, right? What if PGE wanted to put nuclear waste right in our neighborhood, right? It's a little outlandish, right? But, it gives our students an opportunity to relate it to themselves. And so they have to kind of think about some arguments just kind of on the spot for, yeah, please put nuclear waste near my house, or keep that stuff away from me. And of course, a lot of students are going to be here, but we ask them, why? Why would you not want that next to you? And we walk our students through engaging in what we are calling an internet flash debate. So this is something that you might see being discussed on the internet, which we know is not very successful most of the time, right? And so there's a little bit of information here, and we have a give one, get one protocol where we have A and B partners. And, as we go throughout the debate, we okay, did anyone win? Well, not really, right? And it's just a means to prompt students to begin asking questions. Like, what do we need to know in order to decide like if we should store nuclear waste in certain locations or not, right? And we've got, our slides as in other openers that encourage our students to build this driving question board. And this driving question board should be interactive, right? And students should have the opportunity to use their own voice to ask questions that they might be interested in. I've done this quite a bit. Let's see, I'll kind of click through here. I know a lot of teachers have hesitation. They haven't done this driving question board before, but it creates a really nice experience where students' voice is centered, and they get to write down their own questions and their own wonderings. I know as teachers, sometimes we worry like, well, what if their questions aren't related to the things that we're going to be teaching? Like, isn't there a set curriculum? And I just want to give you an example. These are some actual questions that my students, who are typical students, have come up with in the past. And if you look at these, like, they're not profound questions, right? What does nuclear mean? Well, at this point, we just went through Unit 2. I would assume my students knows what nuclear means, but this was a question that came up, right? Some of them are a little bit more profound, right? Some students have a background knowledge related to like the global climate crisis, and maybe they have some ideas already about how nuclear energy could help or not help with that. So just kind of take a look at this, and this is just here to give you some ideas to help encourage you to create this driving question board for our students to be engaged and to share their voice. And you can share with students. Let me move my little toolbar here. But in the questions, you can kind of share, okay, well, these are some of the questions that we're going to be exploring. How many of the questions that we've come up with just in our quick little brainstorming here, where do you think that they will fit? And is there something missing? Do we need to add a little bit more here? And I've taught Unit 3 quite a few times, and pretty much all, 95% or more of the students' questions fall within our task sets. So it's a great way to engage students and get them, thinking about the things that we want them to be thinking about as we're introducing content. All right. So if you have any questions, you can put them into the chat, right? And we've got our document that we're kind of keeping track of on the idea capture tool. But the big key takeaway here is that nuclear technology has advantages and disadvantages. Students should be kind of thinking about that, and that's what we're going to explore. Okay. So that takes us through task set 1, which is awesome. We got 1 down, and now we're headed to task set 2. So in task set 2, those of you that said you're looking for shorter activities, this is a pretty short activity. It's all about how elements are made in the stars, forged in the stars. And essentially we have a short video for our students, and it's a PBS Nova video. And then they are going to choose a reading of their choice. We have a bunch of different leveled readings here. And if you want to go ahead and click on some of these, you'll see some of these different levels. And then they're just going to write up a summary. So this is a very like traditional classroom activity, nothing really fancy here. But the idea is that we're introducing our students to how elements are made and what are their parts and where did they come from. So let's take a quick look, at the teacher notes for this. So just to kind of point out where these things are, you can access the teacher notes from our walkthrough, right? But the main way that we feel that teachers might be accessing their teacher notes and the resources is through our unit planner. So we did task set 1, right? And then we're now on to task set 2. So we have access to our teacher notes right here. Okay. Now we know a lot of people are also accessing our resources through the shared drive. So just to kind of point that out, I'm going to take you through my shared drive, which has a lot of random shared drives that I have, but we see the PDX STEM restricted access folder, right? This is the one that you have to fill out the Google form. And in Unit 3, we're talking about task set 2. And here's the teacher notes. So 3 different ways to access the teacher notes. As a council, we've spent a lot of time putting in more supports for you all so that you can help your students the best way possible. So you can see here in the teacher notes, same thing from the walkthrough, same thing from the unit opener. We have a list of materials that you might need, like maybe if you want to use some highlighters for your students to read. We have some links to Avid, marking the text strategies, if that's something you would like to use. And then here's all of our readings, our articles. And we tried to put as best as we could some like grade level readings. So, you know, in terms of differentiation, you know, we don't have anything that's below 9th grade. It's a little bit hard to find that, or like, but hopefully this is helpful for some of your students that might just need an easier or shorter read. We also have some sentence frames and CR resources for your students to use as they're writing up their summaries. And hopefully this looks familiar to you, as this is a common resource that we share across our courses. Okay, so that is task set 2, right? So we're encouraging our students to do a little learning by watching video, doing some reading. There's not a lot of opportunities for students to do reading in the course, and that's something that we're working on, is giving our students those opportunities since we don't have a textbook, right? So the big key takeaways here for our students is that stars create the elements. And in part of those readings and conversations, there are some details about some elements being stable, some being radioactive, and essentially this idea that elements can change, right? Like their structure can change. And so they're introduced to that, and then we're going to talk about it in the next task set. All right, so I've covered task set 1 and task set 2. Do make sure if you have any questions, you're putting them into the chat there, so Christy or myself can answer them. You're welcome to turn off your mic, your mute, as well if you have a question that you would like to ask. Oh, that one's not there. Let's see. Oh, okay. That one seemed to not be available when on slideshow mode. Okay, so our next task set is all about stability and radioactivity. And if we go take a look at this, just to look at our unit planner this time, just to show you kind of the different way things are organized, we can see our essential question is, how can we predict if an element is stable or unstable? The phenomena is that, you know, some things are radioactive, right? Which comes up with a lot of our students and the questions that they're asking. The end goal here is that our students can identify positive uses of radiation, and that students can identify an atom as unstable or stable, right? So there's kind of three parts to this activity, as I have outlined on our slideshow. So we'll head over to the slideshow to take a look at that, but you can see there's some of like the main key points here. So we have this resource here, which is a document that you can print out for your students, and we recommend laminating them, cutting them, and then kind of jigsawing this, giving these out to student groups. So one student group will get this first part. Part A is at the bottom. I'm not sure what happened there with the formatting. But you know, one student will get, a student group will get smoke detectors, and they'll have a little bit of time to explore this. Another group will have how radiation is used in medical diagnoses. And so you give your students some time to just read through this. If you want them to do additional internet research, fantastic. This can just be a means to get them started, or this could be the sole resource that they use. And then you just do a little classroom share out. The main idea is that after the share out, students then have multiple examples of how radiation can be used in a positive manner. I love that we start with this, right? Like, we're not starting with nuclear power, nuclear, like the negative effects, right? Like, we're starting with the positive. And I think that's because that's what gets forgotten a lot. So I like this. This is kind of not usually what students are thinking of when we're talking about nuclear technology. So it's a good little hook. My students have liked this. I teach biomedical or health science related classes. So my students personally, they love a lot of these because a lot of them are health related, right? You can see health science, medical related. So it's a good little way to flip the script a little bit for nuclear technology. And of course, you're welcome to use this like in a digital way if you wanted to make these like slideshows or something like that, right? You have access to the document, and you are welcome to add in different things that you might want to add. So that's part one of the activity, the positive uses of radiation. And then the next part is where we give students access to this. I give them access to this as a digital file. It's a little bit easier to see. I know I think we've tried printing it out, and it's really hard to see. But essentially, I'll zoom back out. It's a radiation dose chart. And I know that there's some other, and I think we need to find some of these. There's some other like websites or like little surveys where they can complete this work to see just on a daily basis how much radiation might they be exposed to, right? So it's really small, but up at the top, like if they have a chest x-ray, right? Or if they go to the dentist, and that's not daily, it's probably yearly or every other year, but they can just kind of do a little calculation for themselves. How much radiation might they be exposed to, whether it's a daily basis, a yearly basis, or maybe even in their lifetime, if you want to do a little bit of a longer calculation. So this kind of does a little bit of a juxtaposition there with, you know, there's positive uses to radiation, and then also like, okay, well, we are exposed to radiation, right? So yeah, this is a pretty good one. It's a little hard to see, so you might not want to print this one out. Or maybe you have access to a large format printer and you could print it really large. That might be cool to put in your classroom as well. So that's the second part. And then the third part here is a really awesome video. I know I like this one. Christy, I know she likes this one. But this is the most radioactive places on Earth. Does anyone know some of the most radioactive places on Earth? Does anyone know?
I always take a poll with my students before we start the video. So they say, kind of the things you would expect to hear them say. But then they're always amazed when you get to the end. So we won't give away the end. What is it, like 11 minutes? Yeah, it's not a hugely long video, but he, you know, he's so good. He does such a good job with his videos. Yeah, they're always surprised at the end. So
Yeah. So this is a great one. We think this is like a must watch, right? Like YouTube videos, it's hit or miss. You know, there, some of them are great and people have different favorites, but we have this one like actively included within our unit planner. So you can see here, like it is linked right there. Usually when we have different videos, like we kind of list it as like an optional if you have time. This is one that you don't want to miss. So if you look at the teacher notes for this, we have the specific details here for how to go about this. I spent some time trying to put in some of the timing for this. So if you have shorter class periods, hopefully you can make some judgments as to like which parts of these activities you can do on different days. And then the other really big part here that I didn't specifically mention, but I do want to call out now, is that when you are discussing the positive uses of radiation, that's a fantastic time to introduce some career learning. We're always looking to put more career learning into our curriculum. But we have a bunch of resources here that are career profiles and some videos related to nuclear medicine and nuclear medicine technologists. I know I've taken my students to different hospitals, and some of the techs have chatted with us about some of the different safety protocols and all the kind of cool stuff about working with nuclear medicine. So we highly encourage you to include that. You can include it as you're doing that little mini task of the positive uses of radiation, or you can include it later on in the activity, whatever works best for you, right? And then the last part here, we're guessing this will take your students more than 20 minutes, right? But maybe that's all the timing you have left in your class, is just to do a little practice with the band of stability. This is probably a little bit more classic nuclear chemistry, right? That you're probably a little more familiar with. This is where we get into the content a little bit, where we are talking about atoms being stable or unstable, and talking about this, you know, band. And so students are doing their best to use the graph here to figure out how many protons, neutrons, and electrons. And then they've got a couple questions. Here, the formatting looks a little weird because this is a Word document, but it opens up just fine. So if you want a formative version of that activity, we actually have a code, so you can copy that if you use formative. It used to be Go Formative. So that could be something that you choose to do in class. That could be extra practice, homework, if your students do homework, right? And we've got some other resources here to help you emphasize or revisit the idea of the nucleus and stability. So that is task set 3. Back to our slideshow. Oh, here's our little bit here about their career learning. And then the big key takeaways, our students are learning that some nuclei are unstable. They don't have the right ratio of neutrons to protons. And some of this might have been, you know, some concepts that they're building upon from Unit 2, where they did the build an atom activity. And so these atoms try to become more stable or have the right ratio. And we see that they have some changes, right? And we call those ones radioactive. And this radioactivity could be used for good, but it can also be harmful to us, right? And then, of course, if you touch upon those career learning, students can, you know, learn more about being a nuclear medicine tech, which is awesome. All right. Any questions about task set 3? Oh yeah, flame test lab. Our chemistry teacher is doing the flame test lab this week. So it's an oldie but a goodie. Okay, task set 4. And don't worry if I go through things a little bit quicker and you come up with a question about a prior task set, you can still put that in the chat or on our idea capture tool. Okay, so for this one, task set 4, we've got types of radiation here, and this is maybe where students will recognize some of the things that they've heard about in terms of like nuclear power, right? And nuclear units that you've taught in the past. This is probably directly just right where you started, right? So we've got things set up here. This task set does take a little bit longer, but I think it's well split up if you have shorter class periods, like 50-minute class periods. There's kind of some start and stop points, which are really nice. So the first resource that I want to show you is the nuclear power and types of radiation slideshow. Again, this is just to get our students engaged in the work. We've got a little warm up here, but then we start sharing with them, you know, how we create energy with nuclear reactions. We've engaged in wars with nuclear reactions. And then of course here, this is what we kind of have already talked about a little bit, but maybe some of them might know a little bit about some cancer treatments, right? How we use radiation to treat cancer and get rid of tumors. And we get into radon, which might be more familiar to some of our students, maybe who live in the Portland metro area in Oregon. And there's a video that goes into, this is a TED Ed talk about the challenges of nuclear power. And it's really just getting our students to this point here where, you know, if we use uranium as one of the elements, right? What happens to the uranium that doesn't fully react? What do we do with that? And then it gets us into our decay reaction sort. And this one is a little bit trickier. Up to this point, the task sets, you know, have been pretty straightforward. But this one, we've got some resources here that we're going to show you. There is a student template that you'll want to make sure that students have. And this is a great one to print out for your students. And then we also have this decay chain sorting activity. And in the past, I know for some teachers that hadn't done this themselves, this one was a little bit trickier to grasp. So I spent some time last night like going through the teacher notes to try and make sure that there's a lot of details there for you. But essentially, if we have a reaction that starts off here, if you see this reaction, this is a whole decay chain. So like all the way down, right? We can see where it leaves off or the ending atom. And then there's 3 groups of observations. There's observation 1, 2, and 3. And what we're asking students to do is to sort through these reactions, these individual reactions, right? So like I'm highlighting individual reactions right now. There we go. We can see a little bit better, right? So we have got individual reactions into some similar observations. So to help you understand this a little bit better, I'm actually going to take us to, okay, is this going to take us? Nope, that's not where we want to go. We're going to go to the teacher notes. So we're on our unit planner, and this is the task set that we're in, and I'm going to take you to the teacher notes just because we're virtual here in our webinar, and I'm going to show you this digital version so you can kind of visualize this a little bit. Students are going to be sorting these reactions, and so you'll need to either provide scissors to your students and be okay with the time it takes to cut things out and the very slow snail pace at which teenagers cut paper. Or my preferred way is to give them different colored highlighters, which are a lot faster, but you can't erase a highlighter always. So, but this digital sort shows you a little bit better. So like, here's our header, but then these have individually been cut out in a sense, right? Can you see that? So that students can sort them, right? Whenever we ask students to sort things, it's always hit or miss what we're going to get, but that's the skill that we want our students to be working on, right? Is like, okay, can I identify patterns in chemical reactions? So, as you can imagine, some students are going to sort these by, okay, here's all the ones that let off gas, right? So I don't want to mess up this order too much, right? But here's all the ones that let off gas, right? And we're going to put these into a group. And then we start writing down the way that we've sort these. Okay, so on our student document here, we are encouraging our students to categorize the reactions into 3 different groups and then to list what they have in common. And so they have this organizer here in front of them, and they are going to, put some details down about how they sorted these. Now, if you wanted to, you could have students rewrite the reactions, right? So they could, I've got to go find amongst all of my tabs. There we go. They could write down, U-238, TH-234. They might not know a lot of nuclear notation at this point. So that might be something that you want to go over with them. And we have a resource right here that kind of helps them get started. It doesn't entirely go over it, especially with the types of radiation, but it's enough to get them started. You could have them glue and paste in the individual pieces of paper if you want a really kinesthetic opportunity. Or you can just have them name them, right? They could take a picture. If you're doing this digital, of course, they have this Jamboard, which Jamboards are disappearing. So we've got to that might be something we want to write down, Christy, is that we need to probably change this into a Google slide or something. Jamboards are going away, although I think Lucidchart, which is part of the Google Suite now, I believe, or will soon be, is a good option. Lucidchart, I'll put that into the chat in case you are teaching online and are looking for an option, or maybe in the classroom. I have a paperless classroom, so I kind of like that students can manipulate this and move this around. But sometimes it's nice to have a kinesthetic opportunity with cutting and physically sorting with our hands. All right, so let's go back to our slides here so you can kind of see. So here are the directions, right? We're asking our students to sort these. They are grouping them, and then we're asking our students to share out their findings, right? How did this group over here, how did you guys sort? How did you sort over here? And they're verbally sharing out. They can also move around the classroom. They could check in with other groups to see how those groups were sorting. Oh, whiteboard.chat. All right, Cynthia, I'll have to look at that. I'm going to write that down. I'm always looking for new cool digital tools. So once they share out their findings, then our job as the teacher is to be the facilitator to help get them back to the place that we need them to be, whether they sorted things out the way that we wanted them to, right, or not. But we start pulling them back in to get everyone on the same page and introducing that, okay, these atoms that were here, starting with U-238, right? The ones that give off gas, it's not a hard sort. So I think students, they get to the right place. These ones, what do they have in common? What are we noticing about the change in mass, right? And you might need to remind them about what is the mass? How do we know the mass, right? And there's a bunch of questions here to prompt our students. The whole idea is that we're introducing them to alpha decay or alpha radiation, and they are going to draw some models of this on their handout, right? So this is the handout that they have, and as we are exploring these, they're going to be filling out this information here, and we'll walk them through alpha decay, right? And then we'll say, what about the others? Well, here's beta decay. What do we notice about this? And just through that whole process, right? And then finally, we've got gamma radiation. So hopefully by the end, the students have their template completed and they've got models of the different types. So this one's a little tricky to visualize, right? If you haven't actually done it before and across a webinar, but essentially they're sorting, and you'll see the sorting. We do the sorting in other units as well. Is there sortings in units 1 or 2? I don't think there's any sorts in unit 1 or 2, but we definitely have some other sorts that students will do. I know in unit 5, unit 4, but mostly 5, I believe. So they will do a similar sort or similar type of activity later. All right, please leave questions in the chat if you have questions about that one, because I know in the past that one's kind of tricky to wrap your head around in terms of how to set that up. The teacher notes, let's see, task set 4, teacher notes, I believe I tried to do my best to kind of clarify some of the specific directions here in the teacher notes. Okay. And then while we're still doing the activity, now if you need to have a new class period, great. Students can return to the next part, like the next class, if you have shorter class periods. If you have longer class periods, then you might still likely have some time to look at this interactive. This is a CK12 interactive, which we have some of these resources. You do need to sign in with Google. So there's a little note in the teacher notes about this. But essentially students are going through a simulation of all these different types of reactions. So now that they just did the sort, and then we took some notes about these and modeled these different reactions, now they can see some visuals of these reactions and how they occur. And it also gives them the equations, right? So that becomes a talking point of like, okay, let's look at these equations, right? Let's look at all this nuclear notation. So just as a reminder, we've got a little support here, right? How do you write out or model alpha decay? They took that in the notes, but the simulation, it works well. Yes, Miro boards, I like those too. So, going through, there's also a PhET demonstration that in the past we had our students do the whole PhET, but this is one where it doesn't work on the Chromebooks, or last time I checked, it doesn't work on the Chromebooks. So this is one that as a teacher projecting your own computer, you should be able to go through and also demonstrate this. I like to do this the next class period, right? To show how this works and maybe do some additional modeling of this one. So there's alpha decay, beta, and then there's fission as well. Okay, so we have a couple options for additional practice. You'll see on our unit planner here, we've tried our best to kind of tidy up this column. There used to be a lot of different resources here, and it can be a little overwhelming, right? Like, which one do I choose? So we've tried to be really intentional about this column. So we have this as an additional practice. If your students need additional practice, this can be done in the classroom. This can be done as homework. This could be done later as you're doing a review, right? at another date or after an assessment. If you have a short little assessment and realize that your students need some more support, this is what you can give them. So this is just a resource that students can use, right? These probably look familiar to you. A lot of this is identifying patterns. That's why I like that sort, because it gets our brain thinking, right? As soon as we see this helium, right away, we have an idea of what type of decay that is, right? Students can recognize this, right? And when they see the other notation, that should just be a clue, and they can identify the type of nuclear decay. So these are here for your students to practice. And then there's also a fission and fusion practice as well. And this helps them kind of differentiate, compare and contrast fission and fusion. So you can use this in addition or instead of the other one. That's up to you and what your students need. Okay, the end goal is that they do that sort, right? And then they're using models to predict outcomes of nuclear reactions. And then they're going to write a CER to kind of like summarize and put this all together. So you'll see as we're at the bottom of the student handout here, they have some support. So here's their claim. You know, what happens to uranium once it's used in a reactor? That was our beginning question in our slideshow. And so they have a little bit of writing supports here as they use some evidence and some reasoning, right? And so you can use this just as a completion if you want. You can use this as a little mini assessment, whatever you need to do for your students. Are there answer keys? Okay, that's a good question. We do have answer keys for a lot of things. For these ones in particular, I think some of these were recently updated. So we need to have some answer keys for these. I don't think I've seen an answer key for this one. Christy, have you seen an answer key for this one?
No, I haven't. I would just say generally that is something we continue to work on, is building up our answer key bank. We do not have a lot of answer keys, and I know that's a common request. Totally get it. But it's ongoing project for sure.
Yeah, so if we when we do get them, remember they will be put into you can't really see this, but this is the restricted access folder, right? So we try and keep them there under the task set. So no keys for this one. The hard part is like we're still constantly evolving and making all of our task sets better. And, you know, we'll create an answer key and then we're like, no, this is a much better version, right? And so we come up with a different version of a certain activity or practice problem. So we'll get that. We'll make a little note that those activities in particular, we need some answer keys for those.
Hey, Carly, can you click on the nuclear processes graphic organizer and let's see if that is a restricted.
This one?
Oh, is that it?
Oh, the one that's in, I know which one.
I think I do too. The little half sheet. Someone is saying they don't have access to it, and I don't know if it's a restricted folder issue or a linking issue.
Yeah. So I'm pretty sure. Ooh, that makes my brain uncomfortable. Those aren't in order.
They're out of order. Fission fusion worksheet, is that it? Nuclear processes graphic organizer. Let's try that one.
I think it's under here. This one.
Okay.
I think it's this one.
But you can open it. So
I think it's Nessima. I think Nessima did. Oh, anyone the internet can view. Maybe if you put the link, it's in task set 4. Okay. This one, copy. This is the one that we had trouble with Christy during our
Oh, okay.
chemistry council meeting. Um,
Yeah, what's the
I
sharing on
think
that?
this one.
Anyone with the
Yes, we had
link?
some trouble with that. I think it might be this graphic organizer. And we thought we resolved it, but it looks like we didn't. So I'm gonna leave a little note that one of the graphic organizers is being tricky for us.
Okay.
It's basically a simplified. I think that there's a link to this in the teacher notes. So anyone with the link, but I'm gonna copy this just to see maybe if the internet wants you to have access to it. See if that works.
Yeah, I think that's a really great point, Jess.
Some exemplary student
yes.
example. Yes, I
Great.
love that.
Great idea. I love to put in the keys just in general, like what is we in Beaverton, we grade on a 1 through 4 scale. So I even like to go over with my students, what's a 2 look like? What's a 3 answer look like? What's a 4 answer look like? And I think that's even great for teacher notes too, because then you can really sort of see the progression of student thinking. So totally agree. And I think we'll be including more of those.
Yeah. So here's the hard thing. Unit 3, I think, is probably our least implemented unit, which is really sad because it's my favorite. And it's quick. You'll see when I go over the whole like timing. And so this is something too that if you have amazing examples of student work, especially if it's leveled in terms of like almost there, they've got it, they went above and beyond. If you have students that are willing with their names taken off to have you share that work, we would love that. We have our students, that provide work for us, but we're so busy with some of the like intricate nuts and bolts of providing access to the curriculum that it does get forgotten a little bit. We do have examples of student work for a lot of our labs, in particular in Unit 4. We have quite a few examples of student work, especially that's leveled, different conclusions that are lab conclusions. We've got a lot of that, and maybe in Unit 5 as well. So yeah, thank you, Jess. I've written that down so that we can add that to our to-do list. All right, we've reached kind of the hour, and we don't have too much more that we need to go over. I was originally thinking if we needed a quick little stretch break, but if that's something that you need to do is just get up and move. Most of you have your cameras on, so I'm assuming that you're doing or cameras off. I'm assuming you're doing that if needed. But like I said, we don't have too much more to go over. So let's just kind of hit these last couple task sets. The next one is a little bit longer in the example, but then task set 6, we get it wrapped up and we'll be done shortly here. And then we'll have some time for some more Q&A as needed. All right, so task set 4, right? Big key takeaways. 3 types of radiation. There's different levels of harm that can be done to the body. I think that's the best way to describe it because we have bodies and we can relate to that. And then radioactive elements are decaying until they become stable. Hopefully students are seeing that and we're pointing that out with that decay sort. And they're not safe until they finish decaying, right? Okay, so that brings us to the half-life lab. And this is where we follow our patterns, science inquiry approach. And so students are asked to make a wild guess about a phenomena. And we're using fossils and radiometric dating for this, which is fabulous. We all love talking about dinosaurs, right? Students are writing up a research question, making a prediction, right? They're collecting data. We're graphing data. This is Excel, but most of us are using Google Sheets, right? That's definitely something I should update. They're working hard to make sense of the data. They're engaging in a data discussion, and then they're wrapping things up with a conclusion where they make their data-informed prediction, they state their confidence, and how they might, test this, right? So this should be a familiar pattern for us now. If you teach the other units, right? Our students have done this just a couple times, and now they get another opportunity to do this. So let's look at the teacher slides really briefly. And we'll also take a look at the teacher notes and the student handout. Okay. So this is where we're, telling our students how we're going to identify a mathematical model, right? We engage them in a little bit of background information about the Hanford site in Washington as part of the Manhattan Project. And this is where they make their wild guess. So remember, the wild guess is like, why would our students know the answer to this? And it's super in juxtaposition of, that's not how we should be doing science, right? In science, we're making data informed predictions. We're using our data to help us make not wild guesses, right? So we do this to compare and contrast that. So how long would it take 5 kilogram sample of plutonium-239 to decay until it's considered safe, right? I don't, my students have no idea, right? They're just like throwing out random times, and that's fine. That's what we're asking them to do. So our research question is, how does the number of radioactive atoms depend on time for each isotope under study, right? So we introduce our students to a Geiger counter, which is really fun. There's a little, I think, a video here about Geiger counters and how they work. We help them set up their lab, right? So let's take a look at that. At this point now, this is the Half-Life student lab template. So you can see they're putting in their title, their wild guess, their research question, their hypothesis in graph form. So we're kind of helping them with this, right? Still supporting them in this. And then we give them some details about the experimental design. So there's a couple of different ways that you can do this. I like to do this with physical material. We use candy to represent our different isotopes, right? And so you can change these if you have different colors or different notation for your candies. You can change these. So let's go over to this teacher note so that you can kind of see here. So here's our teacher notes. Task set 5, teacher notes. So we can have the teacher side of how this works. So you can see here, I like to use Skittles. I prefer Skittles over M&Ms because the chocolate just gets really kind of melty, but M&Ms, it's all you can find. Great. And you want some kind of candy that has some wording on it. Now, some of the candy wording can come off. So you might have to like use a permanent marker. That can take a long time though, because you're going to be working with a lot of items here. So I start off with my candy, and then, as students notice that it's hard to kind of read either the M or the little S that's on the candy, I just give them markers and they can notate them, and whichever ones have that notation, then it's marked as stable. Now you're welcome to use other items. I know there's like little discs and different things. Be creative about what you need to use. If you've done this lab before, feel free to put some ideas that you have in the chat. But essentially, students are going to need a lot of these items. I think, let's see, it's probably back on the slides here. Okay, so yeah, they're going to have either their radioactive iodine or plutonium in these little baggies, and they're going to like shake them and dump them out onto the table, and then they're going to count which ones have the star or the notation up, and those are stable, and then count how many of them have no star, right, or are blank, and those are the radioactive ones. And they're going to put the radioactive nuclei back into their beaker and shake it. It's a really loud, it's really loud in the classroom this day, right? And so then they shake it and they dump it. And so they'll do this so that whichever element they have, you jigsaw, you can divide up in your classroom, who has iodine, who has plutonium, and they're going to go through 4 radioactive decays, right? Or half-lives. And students will record this information into Desmos on the teacher notes. And this is also linked on the student lab. They can see the Desmos template. Oh, pennies is great. I love that with taking care of the noise. That's a lot of felt though. I might go a little bonkers trying to get all that felt on there, but I like that idea. That sounds like a good task maybe for some student aides to help with, right? So you can see here, we've got some templates there for using Desmos. This one is tricky, right? The mathematical model, let's go down here, is a little tricky, right? So this is one that you really want to make sure you save enough classroom time for. You'll probably need to like walk around with your students, right? Really checking on them. I'm just trying to get to the slide that might share a little bit more. Here we go. Yeah, we've got some exponential, right? I don't know about you, but like if I showed this to my students, they would just immediately check out, right? Like, I have no idea what that means, right? So you're walking your students through it, you're breaking it down step by step, and that's what all those other slides are doing, trying to encourage your students to make sense of this, and they can get there. They can get there. It's a little bit harder than some of the others, but they all get to where they need to be. And so essentially what they find out, right, is that it doesn't take long. Let's see, we've got all, I'm going to show you where these answers are so that you can find them too. Okay, right here, the biggest difference. Okay, essentially is the iodine 31, the half-life is in days, right? And our plutonium is thousands of years, right? And so it's a lot easier to quickly go through that iodine and then have the plutonium that's sticking around, right? And so we have plutonium-239 that's going through many alpha and beta decays as it's trying to become stable. And essentially the iodine-131 takes 1 beta decay to become stable, right? So we have these different isotopes with really big differences so students can see this, right? And then once we've helped them get through recognizing this pattern, mathematical model, we go back to our wild guess, and we ask our students to make their data informed prediction, right? And we've got an actual result for our fossil here. So I like this, does a good job of following the patterns approach to science inquiry. It's fun shaking around all those candies. You know, we give our students some support with the mathematical model, but they get there. So we've got the teacher slides, we've got the student template. Our goal is that they're analyzing that isotope data to come up with that exponential decay equation. They come up with an explanation of why, relating it to Earth's ancient materials, and they turn in their lab report, right? So really good experience for our students. At this point, maybe they haven't written a full lab report. Maybe you've been focusing on different aspects of the lab, and maybe this is the opportunity to turn in that full lab report. Or maybe you're still working on certain parts of the lab, and you're going to get to that full lab report maybe in unit 4, right? Whatever works for you and your students. Okay, so that is test set 5. The big key takeaway being that we can use half-life, which is the amount of time it takes for 1/2 of our radioactive isotope to decay, in order to make predictions about the age of fossils or rocks. Pretty cool. Students like this one. All right, and then the last bit here, I could probably talk about this one for a long time, but I do know it was daylight savings and it's feeling a lot later than it actually is right now, and the sky is getting dark outside. So I'll just share that this is one of my favorite things that I do with my students in all of the courses that I teach, and I get to teach some pretty cool classes. This is one where I walk away from this culminating event super proud of my students, and to be honest, like with hope for the future, right? Sometimes that's not always the case when we're working with our students. We walk away at the end of the day and we're like, oh, wow, right? Are they ever going to figure it out, right? But this one, I've always been impressed with my students and the insights that they share about nuclear technology. Was it good or is it bad? And the arguments they have either for or against nuclear technology, and how well that they communicate with their peers. This is one, like I said, it gives me hope. And the key is really giving our students enough support. So I want to kind of show you this. You have some options here, but I feel like this is the meat of the supports that we can give our students for this test set. So you can prepare your students for a Socratic seminar. You can prepare them for like a really detailed flash debate, or you can also like do a combination. So we give our students this, nuclear tech, good or bad. And then I have a writing assignment for my students. I'm really big about technical writing. So I try to encourage students to get as much practice as possible. But I asked my students to pick 2 of these essential questions, and they can, each response for each essential question can be 2 to 3 paragraphs. I'm like, if you only want to write 2 paragraphs, great, that's totally fine. A lot of my students will write more than this, but they don't have to. They pick 2 of the essential questions that they relate to the most. And then I give them a whole bunch of time throughout the unit and at the end of the unit to do a little research. So if you go down and scroll down to these different tables, there's tons of links here. And this is something that I'm always like trying to check for like updates and stuff. So we're finding different things, but there's different topics: nuclear radiation and kind of like the essentials of radiation, nuclear power, nuclear waste, tons of articles, tons of videos, environmental justice and indigenous perspectives. A lot of my students pick these, right? Like they're really great about social justice and environmental justice. So I love that. I encourage them to do that if that feels right for them. There's nuclear medicine, nuclear bombs, a lot of stuff about history. If you have students that love history, they can pick some of these resources. There's a lot to choose here. And then there's some supports here for like organizing their findings. So they'll put, what are the things that I've found that are beneficial? What are the things that are the drawbacks? And just organize all of their thoughts here and giving them some supports to help them with like their claim, evidence, reasoning as they're writing up their response to each essential question. And they're only picking 2. So the way that I do this gives my students the stuff that they need to engage in a conversation. That conversation can look like a Socratic seminar. We have supports for you. I'll show you in the teacher notes for that. It can also be a flash debate. I've really grown to like flash debates. It's a little, there's a protocol, but it feels a little bit less pressure than a Socratic seminar. So we have this protocol here for how to organize your classroom to have this flash debate where they have short amount of time to like talk to individual students and present their argument. And they can go back and they get to caucus, right? Which is a great term. They get to caucus, which means they get together with their like-minded thinkers or other students have similar opinions to them and come up with some really great ideas and evidence that they can use as they go back to have another conversation, right? So this is a really fantastic protocol for encouraging student talk and encouraging students to like come back with even stronger arguments and stronger points where they, in a sense, I feel like they get to talk more than just like a standard like classroom Socratic seminar or sit all together around a circle, right? Like a fishbowl kind of conversation. So I really like this flash debate protocol. You can also do a shortened version of this where you like shorten the time. And you can do this as students are preparing for a more formal Socratic seminar. Okay, so we have a lot of notes for you about how you can organize this. I'm going to go down to the teacher notes for task set 6 right here. We have organizers for students in the flash debate. So again, here kind of the different options. You've got the Socratic seminar and the writing assignment. There's resources here for students, like for student talk. I will print these out to give students so that they can sit there with sentence frames to help them engage in the conversation. And then here's the flash debate options. We also have a little slideshow where if you wanted to do a really quick flash debate, like I said, and a deeper Socratic seminar, right? That's probably like the longer version of what you could do. And then if you're limited on time, right, which is probably a lot of us, there's a stronger and clearer protocol here that can help students like clarify their statements and again, work on the language that might be needed to engage in a little bit of a deeper conversation. And if you didn't want to do the writing part, you don't have to do the writing part. I like it because that's what gives my students substance for what they want to talk about. So this wraps up our unit 3. This is the last thing that we do. And like I said, I'm super proud of my students on this day. They do a phenomenal job. So essentially, the big key takeaway here is that there are evidence-based arguments for both positive and negative uses of nuclear technology, right? There is an optional opportunity in task set 7. I think it's actually 8 that we've called it now because I think 7 is the assessment. But this is one that focuses on earth science. Not a lot of schools have a strong focus on earth science, and this is kind of a perfect little opportunity to get a little bit more in there related to radiometric dating. So, okay, so that wraps up our unit, which is really awesome. We did it. Great. As you're thinking about assessments along the way, we've got a few different resources for you. I'm going to show you this rubric one, but we have a test bank that's available in the restricted folder. We have an example of a Unit 3 test. And then Christy has also put together something related to collection of evidence. Did you want to share that, Christy? Just briefly. Do you want me to click on this?
Yeah, why don't you click on it and I can talk about it a little bit.
Okay.
So one of the things that I really learned during COVID, among a long list of things, is that we really needed to have some alternatives to our, sort of standard testing protocol. Like a sitting down and taking a unit test was just not a thing during COVID, or it was a very complicated, complex, difficult thing to manage. And so what I started doing was offering some, we had a few options for assessments. We could still do a unit test, and that was through Canvas, and it was more of a, traditional timed and, et cetera. But we also had some more open-ended type of things that definitely took more time than just taking their traditional unit test. And I would tell the kids up front, like, not, not trying to sugarcoat this or make it, more or less than another option. I think it does take more time, and that might be totally fine with you because you really dig in and kind of are really enjoying the process. And that's fine. It's just whichever one is going to work for you. So for example, this particular one is a collection of evidence. And so when, so we've got our rubric here. Like I said earlier, Beaverton's a 4-3-2-1 scale. Notice I didn't even put the 1 on there. Anything less than a 2 is a 1, right? So sometimes it's really hard to write descriptors for 1s without using kind of negative language. So sometimes I just leave it off and I just focus on the 4-3-2. So what information are we going to be talking about in our collection of evidence? So that's listed in the upper left-hand corner. Where do elements come from? Stable, unstable, all the topics that we've studied in the unit. There's going to be an assigned problem. So, and then students are going to be showing examples of their work that explains the problem. I have another version. It's called a whiteboard explanation. And I would give them an assigned problem, and then they would film themselves explaining out the solution to the problem. And then I'm really listening for context and content. So that's what I'm evaluating, is really their explanation. So that's another version that you could do. The collection of evidence is really meant to be, you've already done all of these pieces of work. So now let's take these pieces of work and use them to demonstrate what we know. So I'm looking for thoroughness in their answers. I'm looking for clarity in their descriptions and the way that they're presenting the information. I'm looking for the way that they're presenting it. They're using quality examples that are really emphasizing the point that they're trying to emphasize, right? We're not just randomly grabbing pieces of evidence and saying, yeah, this is a great example of my understanding of isotopes. It really needs to be certainly relevant, but also really getting at how does this show your understanding of isotopes, right? So they have to be pretty thoughtful about that. There's a template there that's linked. And so kids would make a copy of that. So I just got them started basically on it. You can know, yeah, great. I got them started on it. I put in the graph. This is something I want you to talk about in your collection of evidence. And then if you go to the plus sign, Carly, and show like you're going to add a slide. The little menu. Yep. Then I put in a bunch of other templates. These are the things that you can choose from, but you can add other things too. I think this was the example. One of them is the example of the, the example of the problem I wanted them to solve was not in here because I assigned those individually so that students weren't answering all of the same, they weren't all answering the same problem, right? So I did tailor that a little bit for individual students so that I could really kind of see their particular understanding as an individual. They could do sequencing. I'm bringing them back to the kind of the infographic with notes there. They're doing a reflection at the end. And then they're putting in slides that have their own evidence from their work over the unit. And then they're doing some explaining on their slides. So they're adding a bunch more slides to this deck. And if you go back to the directions, yep. Those are the required slides. You're going to put some more slides in, and then the, sort of 2/3 of the way down, discuss where do elements come from. Again, there's the content requirements that are needed. I'm going to be looking for those content requirements when I evaluate your slide deck. Look at the rubric. We're going to turn it on this day, etc. Sometimes I would show an example in class without you know, spending too much time looking at the slides. I just wanted to give them kind of an overview, or I would do it from a different unit. I would show the kids an example that some other kids did from another unit, just so they have kind of a big picture vision of what it is I'm looking for. Students really liked these options. You know, if they were kind of self-identifying as like, I'm not a great test taker, I really like to have more time to go through and explain. I can really think about it more. I thought these were great options. And then when we went back to the classroom, I continued to offer them because I thought they were just, the kids really liked them. They really liked having that option. So something to think about. If you want to vary the assessment, and then you really have student choice in that, the option for student choice, especially around assessment, especially around evaluation, I think is always certainly appreciated by students. So yeah.
Thanks, Christy. I love that.
Yeah.
Other option is important for students, or as a, you know, another opportunity, right? If they don't do well in a unit test, they could do the collection of evidence opportunity. So, yeah, so check those out. I don't want to take up too much of your time. I know we had like the 4 to 6 hour window, but I do want to get you out and go in about the things that you need to do. I just want to point out this is a new resource. Jomei, she just finished this up today, putting in, you know, a more formal rubric for each of the task sets. So you can see down here at the bottom, each little part here has the different NGSS standards, right? And then we're still kind of working through the last task sets here, but we're working on this so that you can use this and assess your students as best as possible. Okay, so those are our assessment resources. We're going to formally wrap up things here. And then I'm going to just take a quick look at the idea capture tool to see if there's any questions. If you don't have any questions or you don't need any other information, and you've taken attendance, right? You've logged in on both the form, and if you're getting paid the Wild Apricot, then you're welcome to sign off. Like, thank you so much for being here. If you have some questions, we've got a few minutes for some questions as needed. But we just appreciate the work that you're doing for your students. So hopefully this was helpful. We love feedback. So if you have any feedback too, or questions that you want to put here on the idea capture tool, which I'm gonna try and put up. There we go. My goodness. Happy to have that feedback as well. So, all right. Thank you. Christy, am I missing anything before bulk of people sign off?
There's been a couple questions about the attendance link. I would say check slide 3. You can fill out that Google form and that will get your attendance logged. Pam asked a question about the Unit 2 rubrics, and I think, Carly, tell me if this is your understanding too. We were able to get rubrics done in time for the Unit 1 webinar, but not Unit 2. And so I think we just need to finish those up and get those posted, but I think that's what happened. Is that your recollection?
Yes, that is
Okay.
what I am remembering too. We had some updates that we made a little bit to like the phenomena. And so I think that's where a lot of our time was spent. And Jomei is busy. She's still wrapping up Unit 1. She's grading all of her climate change projects right now. So she's been our rubric creator there. So we'll get those.
Yeah, we will. There's a question about registering through Wild Apricot, but you still do need to fill out the Google form for attendance.
Yes.
So sometimes people register, but then they aren't able to come, right? So the Google form just sort of logs that, yep, you were here, you filled it out, and you should get paid for that. So please do fill out the Google form just to make sure. Great. Laura, I saw your comment about wanting those rubrics. I will certainly bring that
I
up
know,
at our
I'm writing it
at our
down
next
too. We're
next
meeting next
meeting.
week, so we'll move that to the
Oh,
top of
okay.
our list.
Okay, Monday
Yeah.
is our meeting, so we'll make sure to bring it up then as well. In fact, I have our agenda notes open, so I'm just going to add it right now. So,
Yeah.
great.
Okay, I'm just gonna pop down here. Questions, access to rubrics. Yeah, we got that. Yay. 3D assessment. Oh, yeah. Answer keys. Yes. Okay, I wrote down the answer keys so that we can see if anyone has that, because some of us might have that. The 3D assessment, I don't know if that person is still here. I do want to say, Christy, I was trying to find this test example when we were having our conversation last week about 3D assessment. I like this unit test.
Oh, yay.
I think it did a good job. Maybe when we
That's
are
great.
talking about this, Christy, maybe we can look at this one, because I feel like this one does a good job of 3D assessment, but
Yeah, we
just my
haven't looked at
opinion.
it. Yeah, we haven't looked at it for a while, so that might be. I'm going to put that on our list also.
Yeah. Maybe if you want to put the link, because that might be hard for us to find later. But I really like this unit. If you're still here, we've got 13 people still here. I really
Great.
like this unit reassessment. I've used it and it was so easy to grade in terms, like, we have a rubric with it.
Yeah.
And normally this would take me a really long time to grade, but with this rubric and the way that it's set up, I can just go and grade
Yeah.
the students. Yeah.
Awesome.
Okay. Any other questions?
Yeah, I see one here. How did you make your collection of evidence slides in Google Sheets with the pre-made slides? Oh, Julie, let me tell you how much time I spent working on. Let's stop recording, Carly, so I can just
Okay.